This is the final presentation for the CIT 260 class, and my name is Kemish Montes. I'm very grateful for taking this class. So I will explain 5 different topics which are key to what we have learned on this uh, last half of the semester of the term. I'm going to go through um, calling functions from static and non-static objects, the usage of lists, um, the for loop statements, throwing, catching, propagating, um, uh, uh, exception handling, and also the difference using the character streams, the byte streams, explain the difference between them. And I think these topics are very important to learning Java, and more important, the object-oriented programming paradigm. So I will start with the calling functions from static and from non-static objects. I'm going to start with this. In our project, which is Joseph of Egypt, we have to create a pyramid, and our main objective in the game is to create this pyramid where we can withhold grain to save the people from the famine. And in order to save a pyramid, we use different functions. Some are static, some of the methods come from non-static objects. But in this case, for example, in this example, I'm gonna um, I want to know the volume of a certain pyramid. I'm gonna calculate it, and in order for me to get the volume, I'm gonna use a method inside a static object. This method is called calculate design pyramid. And well, how do I know that this is a static? Because this is a capital I. This is a class, and as we can see here, I have an inventory control class, and inside this class there is a calculate or a calc design pyramid, which uses these parameters, and that is a static method. It is called from a static object because this method it's called from a class from the mold. And in the other hand, we have the save pyramid method. And for example, in here, this is a very simple example, and I created this pyramid instance because this is the pyramid that I'm using for this specific game. So I want every game to have a different pyramid with different height, width, and length. And for me to do this, I need to use a non-static function called from an instance from this specific instance, and I'm going to set the height of this specific pyramid. And that is the main difference between static and non-static, that the non-static, which are instances, you can add values to them. They are dynamic and they are unique. Well, you can have a lot of them, but you can make them unique. You can add values to them. And the static methods, those are unchangeable. Those are really unique. They can't change. Well, that was the first topic, one of the most important things, and I took a long time to understand this, but now that I know how to use it, I really enjoy um, knowing how to call functions from static and non-static objects. The other important thing that I should mention is the lists. It is very important. It makes things very easy and very handy. You can use it very well. The enum actor. This is an example of an enum. an enumeration or a list in enumeration is a set, is a fixed list, in this case of actors, and the values that I give to it, they won't change. Um, Neither the values or the specific instances of this list. And also, this enum cannot be instantiated. Um, uh, uh, and in the other hand, for example, I I had to instantiate a an inventory, for example, an inventory list. I created an inventory list as a team. We created an inventory list, uh, wood, ore, grain, hammer, chisel. We created all this type of items. And look at this. This number 8 is it it gives me a length. So my inventory item list will have 8 items in it, and I can go no further. Well, I'm sure there's more complex methods that can make this array further or expanded, but as far as we learn this term, the arrays are also a fixed length um, list. So I'm going to have 8 inventory items throughout my whole game, but the values which are here can change. These values will change as my game starts developing. See, I'm expecting my grain to expand, um, and any other eh, item I expect it to develop to dynamically as I go through my game. And also the another thing I should mention is the main difference between an array list and an array is that an array has similar objects. They should be of the same class, and an array list uses all kinds of stuff. You can store there all kinds of objects, and in our game we don't have a specific. We didn't use the array list. We didn't find a place where you use it. Um, but the array list, I see it as a backpack, as a big backpack where you can store any stuff, any kind of stuff, and it is very dynamic. It is not a fixed length. It can change its length, its objects, and it is. I'm sure it's useful. We didn't see how to use it on our game. Um, so those are the 3 types of lists: the enums, the array lists, and the arrays. And the next thing I should mention, which is very useful, and it also took me a long time to understand this, and I'm still working on it, is the four statements. The four statements. These are very useful, and I saw the power of it in creating a map. And um, well, I did not do it alone. I did it with my teammates and with the help of my instructor. But for example, I want to take this example, the display of a map. In the for loop, the first thing we should do is to the for statement has 3 different parameters, so to speak. The first one is the initializer, so we're going to give him an index and a number, an initializer, and then this index, this is the validation. I think it's called the validation. So as long as my index is less than 11, I should keep going. And this last statement is the increment. So every time I loop through this, my j is going to increment by 1, and that's the way I make sure that my loop actually finishes and then continues on with the code. If I didn't have a finalizer, I would spend all the time in there looping back again. So what this is doing, this is a nested for statement. So I use um, two indexes, uh, and they are both starting at number one. So what this is doing is that every time that I go um, through it, I'm going to print uh, a column divider. That's right here. And then if my location is visited, I'm going to print a double V. And if it's not visited, then I'm going to print the scene uh, that it's at location 1, which are my current values. And um, and if not, if there's not a scene in there, I'm going to print a double question mark. Okay, we're going to see this work in a further explanation, but I love to use for loops. They are very useful. You can nest them to have this type of indexes, and the indexes will go incrementing by one, so that way we can get all the 10 by 10 coordinates in the map. So that's the four statements. And also a very useful tool is the throw catch, um, the handling the exceptions, because you can solve the runtime, the compile errors, like the word uh, uh, text editor. It tells you where your grammar in code is wrong, but it is very hard to well, you cannot make a user not to input invalid data. I think that's too complicated. Uh, mm, Sometimes the users input invalid data and it can break the code. But if we have this try and catch, we can handle those in an amiable way, in a friendly way, um, or even a graceful way, so to speak. Um, so this is how it works. Um, this is a method that it's used to save a file, to create a file and save my input over there. But what if something goes wrong in here? I'm gonna call my game control save report, and it's gonna take me to the game control, and right here the save report. But if this does not know what to do with the exception, it's gonna crash. But thankfully we have this try catch, because if something goes wrong with it, I'm gonna throw back to my game map view. I'm gonna throw back an exception, and he's gonna handle it. So this is very important. I identify a mistake, and then I throw it back up. I propagate it to my superior, so um, whomever is calling me, and this try receives, it catches the error and it handles it. It knows what it does. So the IO exception, which is instantiated by EX, the variable EX, it knows how to do in this place. In this case, it will display the help menu with other messages. But this is very important, because this way you prevent from crashing the code, and it's good just not to. It's good to use it, but not overuse it. Don't try to use it for everything. We can just use ifs or whiles or other type of validation. But it is useful for this type of stuff when you are really risking to for your code to crash. No. So the last thing is the difference between byte stream, character stream, and the byte stream. So this is a very complex, and I'm gonna do my best to try to explain very simply. Like I was saying, for my program to write the code that I'm to write a file into my flash drive, into my hard drive, into my computer, there we have to create a type of tunnel, or yeah, like a type of tunnel uh, through which my characters or my bytes can be translated. So there are two ways I can transport my information: through bytes or through characters. And well, they're all transported through bytes, but how are they translated or saved? So in this example, the buffered writer is from, it's a subclass from the writer class, which is from the character stream. And I'm using this, um, I'm using a character stream in this method. And so I open this tunnel, and I am creating a new file in my computer, um, and it's going to be a character stream file. That means that it's going to be um, translated, uh, more or less, uh, from from the characters. And well, I really don't understand very well how they're translated, but I know that they are transported characters and byte streams. And well, the important thing is what I take uh, from this is that I can print reports. This way I can actually save my game into a file, and then when I want to start a game again, I can retrieve that game. And that is just that's what's about the input output package. um, and the character streams and the byte streams are just two different ways that I can output and input my information. From what we read, we prefer the character stream because it doesn't use the disk space, so it won't make the computer slower. And also because it is a universal, uh, it uses Unicode, while the byte stream uses the ASCII or ASCII. I don't know how to say it, but it's more of a Western thing. And well, that's what we've been taught, that we prefer the character instead of the byte stream. So um, let's show you how this actually is working. So we present this banner, and it's asking me for my name. I'm going to say my name is Kemish, and it is actually my name. So it displays a banner. Welcome to the game, Kemish. We hope you have a lot of fun. So what happens if I start a new game? It it starts a new game, which means I just created all my objects. So all the objects that my game needs are created by now. And um, not I'm not sure, but I don't think all of this work. But um, we can do some stuff. We can show the current inventory, for example. I want to make this bigger. So here it is. It can show me my stock, etc. Um, mm, for example, um, as I was saying, we can print also an actor report. That's actually something I did, and it took me a while. Um, so to print an actor report, we have to enter a file path. This is just the default, so I'm going to call it actor uh, actor list. And well, the console is it is printed a report and saying that it is successful. So it tells me the name. For example, I have my pharaoh. He's the ruler and owner of all Egypt, and it gives me um, the coordinates. So he is at the palace at x coordinate 1 and y coordinate 2, and the rest is also. And for example, if I want to start an existing game, I just enter the game of the game, and I have previously saved some games. So I'm going to say I want to start game one, which is an instance of a game I have saved already. Um, and let's say I want to construct a pyramid, and it's going to ask me for the length. So I'm going to say it's going to be 50 times 50 times 50, and it's going to say the volume of the pyramid is this much. The saved pyramid are these values. So this specific game has this pyramid, and if I create a new game, it's gonna have a different pyramid, and if I open this game again, it's gonna have this pyramid with this length, and that way I have a unique game for every player. And well, um, that's um, the presentation. Like I was saying, not all of it is working, but it works. The methods work in an isolated way. Um, we couldn't make all of it to function, but all the functions are working, and um, I can save my data, and then if I start a new game, I can have that data back again in my game. So that was our presentation. It's been a great experience. It's been challenging, lots of hours working and trying to make this work as a team. Also, we've made a lot of progress together. We've learned together as a team, and it's been challenging. It's been fun, and I can say I'm starting to like object-oriented programming, which took me a lot of time to understand. And I don't say I have understood it completely, but I understand that objects can interact between each other, and they are um, and that objects are units that can become intelligent and interact with others, and that is pretty powerful. That is pretty powerful principle. And well, that's it. And thank you for everything, Brother Jones. Also, it's been a great experience to be with you. And well, thank you very much.